Let's talk about the bisection method to find the root of a function. Given is a continuous function in one variable, and let's say we are checking a logarithm of x minus x divided by 3, and we want to find the point where this function gives the function value 0. What does bisection need before it can start? Before bisection can start, somebody must provide a and b in a way that the function values of a and the function value of b is of different sign. You can formulate that to be the product has to be below 0, because if both are negative, product is positive. If both are positive, product is also positive. If the sign is different, then the product is negative. Okay, somebody has to provide a and b, and then we can calculate the midpoint and check the sign of the function value at this point, and then we can try to forget half of the interval and iterate that process. Okay, given is a function, a continuous one, and we are looking for the root. Somebody has to provide a and b in the way that, for example, here we have positive function value and here we have negative function value. Then we go to the midpoint of this interval. This is a plus b half. This is the midpoint. And then we evaluate the function at that point. And in this case, the function value is positive as it was here. And so we can forget this interval. We know that in this interval here, there must be a root. And then we can iterate that process. Now take the midpoint of that interval and check function value, the sign of the function value, get rid of half of the interval and work with this new interval here. And iterating that process, you will find the root. Okay, this is a very simple algorithm and it's very easy to understand. It's very easy to understand, and so it's also very easy to implement, or it's easy at least to implement. But be aware, somebody has to provide a and b. The disadvantage is that the user is the one who has to provide these initial a and b, and that's a big disadvantage, because for functions like that, how can we know where the root might be? And in this case, we have several roots, 1, 2, 3, and our algorithm is able to find one of them. The algorithm can find only one root. Let's illustrate that. If you want to find this root, you have to provide maybe this a and b. To find that root, you have to restart the algorithm with a new AB which fits to this root. So maybe this is A and this is B. But how can the user know this A and B? It's easy to know if you know the root, but the task is to find the root. So normally you are not in the situation that you know where the roots are located, and so this is a big disadvantage. Okay, the convergence rate is only linear. Okay, linear convergence is not so bad, but maybe other algorithms will have a higher convergence rate. So this is a only linear. Compared to the others, it's an only, as we will see. Okay, this is the code how you can implement. First, we check the sign of the function at a and b, and if it's of the same sign, we tell the user please provide appropriate initial values and not initial values like you did. And I implemented that a corresponds to a positive function value, and if it's not, I swap a and b, and so we can work here with a more simple if-else. Okay, we iterate as long as the length of the interval is more than this tolerance. Then we calculate the midpoint, we calculate the corresponding function value. We check if this function value has the same sign as a, then we update a, and if it's the other way around, then we update b, xa and xb instead of a and b. Okay, and in the end we will return the midpoint. A good idea might be to return an interval so the user has full information, but for being more convenient to apply this algorithm, maybe it's a better idea to return the midpoint and not an interval. So this is the code. Please check this code and try to make sense of every line. Let's check an example. Logarithm of x minus x divided by 3. If x is a number, for example 3, then the natural logarithm is a number more than 1, subtract 1, so this is positive sign. Here we have positive sign. The logarithm of a half minus a positive number, then here you have a negative number minus a positive number. That means this is negative function value. And so we can work with that interval, and we see here the function values, as we said, negative and positive. And then we calculate the midpoint, which is for 3.5 exactly. The midpoint is 1.75. We calculate the function value, and in this case it's negative, the same as we have here. So we will replace a. We will replace half by 1.75. So this half is replaced by 1.75, and then we iterate the process and do that with your electronic calculator. I beg you to do that, not only watching my videos, and then you see this iteration process, and it will continue and continue. Okay, we can also do the following. We can call MATLAB with that. So this is the function, this is the a and b we are starting with, and then we call root bisection. I inserted some extra lines that we get information on the screen what's going on, and so we calculate the midpoint and so on. You see this process again, and you see after 21 or 22 steps, in the end we will have this interval 1.8572 and some more digits following, but they are not displayed here in that case. So this is the root we found, and these are the corresponding function values, and we see positive function value, negative function value. So indeed in this interval there must be one solution of the equation here. Okay. Then let's go to our next example, our example with the rope around the Earth. We had this function, and we know that in the interval a is equal, in this case the angle x is between 0 and pi halved 1.5. And then we can work with our function and run our root bisection code, and you will see first midpoint is 0.75. We will replace 1.5, and so it's going on and on and on. And after 21 steps we end with this interval 0.0061762, and the corresponding function values are these. So indeed in this interval here we have a root of our function, and this root is that one. So this is our algorithm, how it works for the rope around the Earth, and we had an alternative with a tangent function, and let's check that. Okay, so our alternative was tangent x minus 1 divided by 2 times the radius of the Earth, and we can again work with our interval. And what do you see? You see exactly the same steps according a and b, not the function values, but a and b. And in the end, after exactly 21 steps, we get the same interval as we had last time. Not the same function values because we have a different function, but a function with the same root. Okay. So these are our examples here, 3 examples, and I want you to be able to perform all these steps for a new function, for a new initial interval, and you also understand the idea of that algorithm, how it works and why we programmed as we did, and I expect you to be able to formulate the code in MATLAB as well.